Hi, everyone. So in this lecture and the next one, I'm going to be kind of splitting this into two shorter parts, just so you can have a little break in between if you want. We're going to be covering section A6, part 1. And so what section A6 is solving equations, so linear equations and quadratic equations, so with some x squareds. This first part, all we're going to be doing is solving linear equations. So first thing I'm going to do is write out some steps for solving linear equations. And these are steps that most of the time you'll be following all of them. Sometimes you may get to skip a step or two, just depending on what equation you were given. So step 1 is you want to make sure that both sides are completely simplified first. So we're going to simplify both sides completely. And there's a couple of different things that this might mean doing. So one thing could be clearing the parentheses. And this is something we just saw in section AR 1.4. So to clear the parentheses, we're going to distribute. This could also mean clearing fractions. So sometimes we'll see one today where we're going to have quite a few fractions in there, and we could work with them exactly the same as we do other numbers. It just makes the problem a little bit harder because then you're working with fractions the entire time, just makes it a little trickier. So to clear the fractions, we're going to multiply every term by the LCD. And it's really important to remember that you are multiplying every single term, not just the terms with fractions. So what we do to one side, we do to the other. That implies all terms. The other thing that we might have to do, and most of the time this is kind of the most common one, is combine like terms. All right, so after we simplify, we want to go ahead and actually start moving things around so that we can get that x by itself. So step 2, we're going to get the variable terms on one side and the constants on the other. So constants are those terms that don't have a variable attached to them. All right, so once you have those variable terms on one side and the constants on the other, you might still have a number in front of the x. So if you have a 2x or some number x, we still have to get rid of that. We want to get the variable alone and positive. So we don't want to be left with a negative x. I want to be left with a positive x. So think x, not negative x. The last thing we can do here, and this is really important when you're on the quizzes and exams, not so much on the homework, because the homework's going to tell you whether you're right or wrong. Maybe on your second or third attempt you're going to do this. But you always want to check your solutions. That just means taking whatever you got for x, plugging it back in and making sure it works. So I'll show you that on the first one or two. And let's go ahead and start with a couple that are a little bit nicer, and then we'll get into the kind of trickier ones in the next segment. All right, so examples, we're told to solve. So number 1, we're given 5x equals 45. So first thing to check here is that the x's are on one side, constants are on the other. Or first thing to notice, not check. there's no actual simplifying we have to do. The only thing that's standing in our way between, standing in the way of having that x by itself is this 5. So first and only thing we want to do is get rid of that 5. And so you always want to do the opposite operation than what you see. So since we have 5 times x, we're going to do the opposite of multiplication, and we're going to divide both sides by 5. What you do to one side, you do to the other. And 5 divided by 5 is 1. So those guys do cancel out. So we're left with x equals 45 divided by 5 is 9. So if we wanted to check this, you're going to take your solution, so 9, and plug it back in for x in the original equation. So we didn't do any simplifying, but if you did do simplifying before you solved your equation, make sure you plug into the original equation, just in case the problem was in your simplifying. That way, it'll completely check the equation, not just the second half of it where you were solving. So plug into the original equation. So plugging in here, we had 5x, so 5 times 9 equals 45. And that is true. 5 times 9 is 45. So we get a true statement. All right, let's try another one. So this next one, we're given 2/3 p equals 8. So this is another one where it's pretty much already simplified. We have a term on the left side with a p, so our variable, and a coefficient. Then on the left side, we have our constant. The only thing we need to get rid of here is the 2/3. So anytime you have a fraction and we just have a single fraction, we're going to see somewhere you have a bunch of fractions. That'll be a little different. To get rid of a fraction, we want to multiply by the reciprocal. So I'm going to go ahead and multiply both sides by the reciprocal, so flipping the fraction. That's 3/2. Same thing on the right. And then I can cancel out those 3's, cancel out the 2's, so we're left with p equals, now I'm going to change this 8 to an 8/1 so I can multiply. And so again, we can multiply first and then reduce, or reduce and then multiply. The numbers are pretty small, so I'm going to go ahead and just multiply straight across, then I'll reduce. So 8 times 3 is 24, over 1 times 2 is 2, and 24 divided by 2, or half of 24, is 12. So we'd check this the exact same way. We'd take the 12, plug it back into the original equation, and just make sure you get a true statement at the end. So some number equals that same number. All right, so let's go ahead and do another one on this segment, and then we'll start a new segment. Number 3, negative 5p plus 4 equals 19. So on this one, we have a little bit more work to do. So on the left side, we have a variable term and a constant. And on the right side, we have our constant over there as well. And so what we want to do is get just the variables on one side and just the constants on the other. So since there's only one variable term here, I'm going to leave that on the left, and I'm going to move this this plus 4 over to the right side. So all the constants are on the right. So we're going to do the opposite of what we see. Since this is a plus 4, we're going to subtract 4 from both sides. That way, 4 minus 4 is 0, and this term disappears. So we're left with negative 5p equals negative 19 minus 4, or negative 19 plus negative 4 is negative 23. And then if I go ahead and get rid of this negative 5, again, think of that as negative 5 times p. Opposite of multiplication is division. So we're going to divide both sides by negative 5. And negative 5's cancel. Make sure you're dividing by the same sign. So I divided by a negative 5 because we had a negative 5 there. We get p equals, now 23/5 can't be reduced and it doesn't divide nicely. So I'm going to leave it as it is. The only thing I'm going to change is a negative divided by negative is a positive. So I'm going to write this as 23/5. Okay, so those ones have been pretty nice. We haven't had to do any distributing yet. Let's go ahead and actually do one more in this segment, then we'll start the next one when they start getting a little bit trickier. So this next one, we're given 5 minus 8k equals 2k minus 5. So this one we have a couple of variable terms. We have an 8k and a 2k, and we also have two constants. We have a 5 and a negative 5. So I want to get the constants on one side, variables on the other. It doesn't matter which side you move things to. So if you want to always put the variable on the left, cool. If you want to keep your variables positive, cool. So you might have to move them in a different way. What I normally do is move the constants to the right and move the variables to the left. Doesn't matter what you do. There's a few different things you can do here. So if you like a different way better, stick with that. First thing I'm going to do here, though, I'll go ahead and move this 2k over to the left. Because we're moving that entire term, we're not just getting rid of the 2. We're going to either add or subtract it. Because it's a positive 2k, we want to subtract 2k from both sides. Just make sure you do it once on each side, so it only gets combined with the k terms. So on the right side, 2k minus 2k is 0k, or just 0, so those guys cancel. And then on the left side, we bring down the 5, and negative 8k minus 2k, we're going to combine those coefficients. So negative 8 minus 2 is negative 10k. And then on the right side, we're left with this negative 5. Make sure you don't lose those signs. Now the variables are on the left, I'm going to move my constants over to the right. So I'm going to go ahead and move this positive 5 by subtracting it. Our goal there is to get a 0. 5 minus 5 is 0. Do the same thing on the right side. So now on the left, what we're left with is negative 10k. And on the right, negative 5 minus 5 is negative 10. Final step, we want to get rid of this negative 10 that's in front of the k. So we can go ahead and do the opposite of multiplication, which is division. So divide both sides by negative 10. Cancel out those negative 10s on the left. So we get k is equal to negative 10 divided by negative 10 is 1. So these ones so far, we haven't seen any distributing or any examples where we have to clear fractions. That'll be in the next segment. So I'm going to stop here. Both of these segments are going to be for Monday, August 30th. So make sure you watch both of these. And then make sure you also come with questions on Tuesday in case you guys want to go through any of these. If you have questions, got confused on any of the steps, we won't be going through this section completely again on Tuesday, but I will go through any questions that you guys have. So come with them if you have them.